Hello everyone. Today's learning objective is students will be able to describe the electrostatic forces between atoms using Coulomb's law. Please take out your notebooks to write notes and open IS5 Experience 2 Nearpod. Thank you. The objective is students will be able to describe the electrostatic forces between atoms using Coulomb's law. Please take out your notebooks to write notes. The warm-up question for today is, write the full electron configuration for chlorine. The answer is 1s2, 2s2, 2p6, 3s2, 3p5. The title of our notes is IS-5 Experience 2, the Periodic Table and Atomic Structure. Please write and draw everything on the screen. What you can do on the periodic table is to use the blocks of the periodic table, the S, P, D, and F blocks, to determine an element's electron configuration relatively quickly. One of the things you can also do with this is to note how many electrons are essentially extra or are full. And this can tell you how reactive certain elements probably are going to be. For example, all of the alkali metals in group 1 have 1 electron in the outer S subshell. Alkali metals are very reactive. Reactivity is typically due to electrons, and electrons that are essentially open or unpaired are easy to move around and cause chemical reactions to happen relatively easily. Similarly, halogens in group 17 have 2 s electrons and 5 p electrons in their outer shell. What this means is that halogens are very reactive because they are only missing 1 electron. Unlike those two groups, alkaline earth metals in group 2 have 2 electrons in the outer S subshell. These metals are not as reactive as group 1 metals. It is much harder to lose 2 electrons than it is to lose 1. Noble gases in group 18 have a full valence shell, which makes them relatively non-reactive. Use chlorine's position in the periodic table to draw a model of chlorine, Cl, that includes the nucleus, core electrons, and valence electrons. One of the easiest ways to do this is to draw a circle, and you can choose whatever color you like. Remember that the nucleus is very small, so we need to make the nucleus much smaller. The core electrons are based on the element in brackets. The element in brackets for chlorine is Ne, or neon. Neon is number 10. Neon has He in its brackets, and He is 1s2. So what we can do is start drawing some more circles. Choosing the duplicate button will probably make this process a lot faster. Remember that chlorine is in period 3, and its valence shell ends in the 3rd shell. So we need to have 3 electron shells shown. For the core electrons, we need to draw 10. To differentiate them, I'm going to use purple for my electrons, and I'm going to go ahead and start drawing my dots. Now for the second shell, you can have a maximum of 8 electrons. Remember, after 4, we have to start pairing them together. For the valence electrons, I'm going to use green. There are a total of 7 valence electrons, 3s2, 3p5. Please watch the video about electric charge and Coulomb's law. Coulomb's law is the strength of the force between two charged particles depends on the charge of each particle and the distance between them. When two oppositely charged particles attract, the particles have equal but opposite charges. But if you have a different charge that is larger than the other, the force of attraction increases. Similarly, if you have the same size of charge, but the distance between them increases, the smaller is the force of attraction. Draw arrows to model the force between two negatively charged particles. Include in your model how the force changes if the charge of the particles change or if the distance between the particles change. The first set is an example charges and arrows. This is essentially your original. What happens if these same charges get closer together? What happens is the arrow gets bigger. But what if they maintain the same distance and the charges are stronger? That is the same result. The arrows get bigger. In the last slide for this lesson, did you meet the learning objective? Please choose how well you did based on today's objective. And that will end this lesson. Thank you very much, and I'll see you next time.